Hello and welcome to section 4.6, which is on congruence in right triangles. So the hypotenuse in a right triangle is the side that's opposite the right angle in a right triangle, and it will always be the longest side of the right triangle. Also, the hypotenuse will never make the right angle. So that's another way to tell which side is the hypotenuse, or the C for the Pythagorean theorem. A leg is the two sides that make the right angle in a right triangle, so that would be your A and a B in the Pythagorean theorem. Theorem 4.6 is a hypotenuse leg theorem. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another triangle, then the triangles are congruent. So basically you're saying that two sides are congruent. And so therefore the third side would have to be congruent. So in the example that I have here, I have a little picture here for you, and then I said that given that CD is congruent to EA, and I have those marked with the congruence marks here, and I'm also saying that AD, this line, is the perpendicular bisector of CE, this line, and I want you to prove that triangle CBD, this top one, is congruent to triangle EBA, the bottom one. And so here I have it started. Actually, it looks like I finished the whole thing. So I said that AD is the bisector of CE, and that was given information. And then I said that triangle CBD and triangle EBA are right triangles. And I drew one right angle in there too, so I knew that. And CB is congruent to EB. These two. I know that because this is the bisector, and CD is congruent to EA. That one was given. Okay, so the two triangles are right triangles, and the CB is congruent to EB. That's from the definition of a perpendicular bisector. And then I can therefore say that those two triangles are congruent to each other right here by the AHL theorem, the hypotenuse leg theorem. So here, for what values of x and y are the triangles congruent by the HL theorem, the hypotenuse leg theorem? So here I have two congruent triangles. This one says y minus x, and this one says 3y plus x. This is y plus 5 and then x minus 5. That should be x plus 5, I believe. Let me add that in there. That's plus. So then down here, the way that you're going to do it is you're going to set them, these two, the two sides that are congruent, which would be this side here and this side, equal to each other. Because if they're congruent, they have to be equal. So 3y plus x equals y plus 5. And then I'm going to go ahead and get the y's on one side. So I moved this y by subtracting it, subtracted it here. That leaves me with 2y plus x equals 5. And then I set the other two sides equal to each other. So the y minus x right here and the x plus 5, set them equal. I moved the x over here so that the x and the y were on the same side. Subtracted it, so I have y minus 2x equals 5. So these two right here are going to be my two equations that I use. And I'm going to have to solve. So the first thing I did was I rearranged the equations, and now I'm going to have to solve this system of equations. Remember, a system of equations is just a set of two or more equations. And so there's more than one way to do this, but the way that I did it, I'm going to set it straight up and down. And I am going to remember that to solve a system, you have to cancel out either the y's or the x's. And the way that I did it was I'm going to multiply by a -2. So this whole side here, I'm going to multiply by that whole equation, I'm going to multiply by -2. So -2 times y is -2y. And then -2 times -2 would be a plus 4x. And then you have to also take the -2 times that 5 over there. So it equals -10. And then I'm going to copy this. I'm going to copy this other equation down again so that it will be set up straight up and down, so that it'll be set up to cancel my y's. So I'm just copying the same equation that I had right here, and then my new one that I got. So remember, when you do systems, you're adding. That's the easiest way to do it. So 2y plus a negative 2y, those are gone. And x plus 4x is now 5x. And your 5 plus a negative 10 would be negative 5. And then I can solve for x by just dividing. Cancel that, divide by 5. Therefore, your x is negative 1. So that still doesn't give me the answer, though. I need to go ahead then and plug that negative 1 in to get my y. So I have my x. I need to plug it in. So I'm going to plug it into my original equation. The y, this one, I'm going to plug it into this one. This y minus 2x equals 5. So y minus 2, and then I'm going to take that times minus 1. I'm going to plug that in for the x, equals 5. So a negative 2 times a negative 1 is going to be a positive 2, so it would be y plus 2 equals 5. And then I'm going to just go minus 2 minus 2. So y then equals 3. My pen is not working very good here, so your y equals 3. So your x equals negative 1 and your y equals 3 for that answer. So you're going to have to remember here how to do the system of equations to be able to solve some of these. So bring that knowledge with you. We will talk about it more the next time I see you. Have a good night. Good night.